In this problem, we have n switches that can either be in an on state or an off state and m bulbs. And for a certain bulb, it is connected to k switches. And this bulb is turned on when the number of switches that are on amongst these switches is congruent to pi mod 2. And we just want to find out the number of on-off states of all the switches that will turn on all of the bulbs. So at a first glance, it's very confusing, and truth be told, it actually is. But let's just break it down slowly. So let's look at the input format, right? So we're given the number of switches, the number of bulbs. And then for the next m lines, so the first line we'll be talking about bulb 1. And bulb 1 is linked to K1 switches. And then for the next K inputs would be those switches. And the same goes for all m of the bulbs. And then in the very last line, we're given P1, P2, Pm, right? And what this line means is that, let's say if P1 is 0, that means if an even number of these switches for bulb 1 is turned on, then bulb 1 is on, right? But if P1 was 0 and the odd number of these switches were turned on, then bulb 1 would be off. Using the same logic, if let's say P10 was 0, if a even number of switches linked to bulb 10 were turned on, then bulb 10 would be working. But if P10 was 1 and a odd number of switches was turned on, then it would be working. But if an even number of switches linked to bulb 10 were turned on, then it would not be working. So basically, if it's 0, we want an even number of these switches to be turned on. This is a 1, we want an odd number of these switches to be turned on. So that's the basic premise of the problem. So the key thing to notice is that m and n are really small, right? And let's say we have the maximum 10 switches. The total number of states that we could have would be 2 to the 10, right? Because for each switch, it can either be turned on and off, right? So 2 to the 10 would be 1024 states, and that's not too many. Okay, so due to an audio issue, I actually just solved the problem, but I'll just go over the details one last time. Okay, so let's start here. We first read in n and m, and then, like you said, we get this value k, and then we have to store these switches. So we want to create some structure in which we say, okay, I will give you some bulb number, and I want to know which switches it's linked to. So what I used was a array of vectors. So now let's say, and I zero indexed everything. So this k1 would be linked to the 0th index, right? So this would be k0 and so on and so forth. So from now I'll just use, so when I say k0 in this input format, I mean k1, right? So let's say, so I basically, where are we here? So I get in k, then for the next k input, which would be the number of the switches, I will read it in, I will zero index the switch value, and then I will put it in that adjacency vector matrix, so the vector array. So what that does is, let's say I look at adjacency 0. The output of that would be a vector of all these switches, right? So now if I just give it in the bulb number, I will get a vector back of all the switches it's linked to. So that's what this does. Then the very last thing I do is I read in all these MP values. Okay, so now we just want to go through all the possible states, right? And then for each possible state, we can just check on our own whether pi mod 2 is true for each bulb. And then if that's true, that bulb is turned on. And then if all bulbs are on, then we increase our answer by 1. Okay, so how do we do this, right? So let's just go over something quickly. Let's look at the numbers between 0 and 7, right? So this is 0, 1, 2, 3, 4, 5, 6, 7, right? So imagine we had 3 switches, right? And each switch can be turned on and off. Now, the numbers I've just written down here are the numbers between 0 and 7 in base 2, right? And if we look at this, uh, if there are 3 switches and we look at the numbers between 0 and 2 to the 3 minus 1, then we actually go through all these states, right? So for the number 0, all the lights are turned off. For the number 1, only this one is turned on. For the number 2, just this is turned on. For the number 3, these two are turned on. And if you look at all of these actually go through all the possibilities of the lights being turned on and off for 3 switches. So what I did was I created a Boolean array called switches, in which if for a index the value was true, then that means the switch at that index would be on. Otherwise, if the Boolean value would be false, then the switch at that index would be off, right? So if you look at this, right, so let's say we had 3 switches in this case, then from I between 0 and 2 to the 3 minus 1, then we just change the values in switches to match this, right? So here, switch J, so this would be index 0, index 1, and the last here would be index 2, right? So switches I'd set to 0, 0, 0, then I go through this function check, which I'll go over in a second, then I'll go over this loop again, and then I'll change switches such that the 0th index is now 1, this is 0, 0, and then I'll keep on changing switches to match all these states, so we cover all the possible states that the switches can go through, right? And now what this does is we basically right shift is this number. Let's look at this 5, right? I shift this number first by 0 bits. So what does that mean? That means I look at this index, right? At that value, right? And then, sorry, that's wrong. If I bit shifted by 0, that means I look at the whole number, and I AND by 1, which means I'm only looking at this very first value. And if this is a 1 and I'm ANDing it with the 1, all that means is that this would be a 1. Now if J becomes 1 and I bit shift I by 1, then rather than looking at this, I'm just looking at this. And now if I AND this by 1, I'm looking at the last digit in this number, which is a 0, and this 1. And 0 and 1 is 0. So then switches J would be 0. So this is just a fast way of using the bits to go over all the states, right? So now that I have an array switches which goes through all the states. Once I have a certain state, I run this function check, and I increment answer by that value, right? So basically what check does is, if check returns true, that means all the light bulbs turn on. Otherwise, if check returns false, that means at least one of the light bulbs does not turn on, right? So what I do is I create this vector called number of lights on, right, which I first set as 0 throughout, right? And then for each of the bulbs, I look at the switches that are linked to this bulb, and then what I do is, okay, now that we have this state called switches, I'll check if the switch length, I'll check how many of the switches linked to a certain bulb is turned on, and I'll store that value in number of lights turned on. So this stores the number of the switches linked to a certain bulb that are turned on, and then I mod that value by 2, and then I check if it's linked to the PI that we got. If they do match, that means the bulb turns on, and we move on and look at the next bulb. But if they don't match, that means that this bulb does not turn on, and therefore not all the bulbs can turn on, so we just straight away return 0. And that's basically everything. And using this code, all the test cases passed. So voila.